Good morning, everyone. We have already completed pointers.
Good morning, sir.
Good morning. Pointers and structures.
Good morning.
Good morning. And unions. Now, this is turn for file processing, final topic of the unit. So we are writing program. Okay, these are the program. In this program, we provide input. It will give us output. It will use only RAM, but not secondary memory. Okay, but not secondary memory. So now we have another concept. It will use RAM and then utilize secondary memory that may be hard disk or pen drive, okay, or some other devices. So how do we create such program which will take input from user and process the input, and later it will be saved into secondary memory. So this type of concept is known as file organization. It can be created, updated, and processed by the C program. Okay, like database. Then word processing software, PowerPoint. All are stored in secondary memory. So this program are the effort of software engineers, which will start from means 15 years ago. They started writing program and started saving the program, and later on slowly it becomes, and it is available at this stage. These are used for permanent storage. And what is permanent storage? This is our secondary storage, okay, of large amount of data. Storage of data in variables and arrays is only temporary. So whenever we are using a variable or arrays, so its runtime is up to program execution. But we want that all the data, whatever we are asking from user, must be stored at secondary memory. So how do we perform this task? So data hierarchy, before going to this, just try to understand what is data hierarchy. Data is very smallest unit and the last unit is bit. Okay, only one space is occupied and the value of bit is either 0 or 1. Now byte is combination of 8 bit. Byte is combination of 1, 2, 3, 4, 5, 6, 7, 8. So total 8 bits are there, okay, and used to store a character, ASCII character. It may be decimal digit, letter, and special symbol. Field. What is field? Field is like name, age, class, etc. So this is field. Name stores similar type of data. Age stores similar type of data. Class stores similar type of data. Like your name is the, so this is group of character conveying meaning. So this is, and you can store your file into CSV format. Nowadays CSV is very common, comma separated values. Okay, in earlier days of C programming, the same CSV file is known as DAT. So this is actually data file which holds the data, okay, which records the data. Record is group of related field. Group of related field. What is the record number 1? Record number 1 is associated with particular name, his age, and his class. So this will become record. Okay. This is field. Column wise is field, and the row, entire row is for one particular person becomes record. Okay. And if we combine all the fields, all the records, it will become file. So group of related field represented by struct or a class. Example, in payroll system, record for a particular employee that contain his or her identification number, name, address, etc. So one record of employee is like of this, and it was started, this C was started, or some other programming language was started as an effort to create or automate the payroll system, because that time a large volume of employees are there, say 25,000 employees are there. How do you maintain their register, and how do you provide cash to them? So better to automate the system based on attendance and target and performance. Okay, so based on these things, the salary will be decided, or payroll system will give the salary. So this gives one example of, this is the whole file, and the entire thing that Judy is written. Okay, so how Judy is written, it represents the field, and this is the database group of related file. So group of related record is a file, example is payroll file, and database is the group of related files. So payroll or personal, all other things are there grouped together. Actually, in earlier days, database was a file. Database was a single file. Nowadays, what happened? Database, like employee is a database. So employee may be categorized with different things, like department, okay, level, and work performance, role. All these are relations. These are known as relations or tables. In earlier days before 2000, or even up to 2005, the same table is used, and the same table is known as database. But nowadays, database is combination of different tables, or related tables. Okay, and that's why these related tables are known as relations. Now here it shows that in this file, Judy Green is stored as a record. So what do you mean by Judy? Okay, Judy is stored in secondary memory. Now how it is stored? So that J character is like this. Okay, whenever you are searching for ASCII character list, so it shows that this is the set of character which represent J, and this J is combination of different bits. So this shows one bit, and so this is the hierarchy: 1 bit, then 8 bits, and then a character, and then character form a field forms a, many fields forms a record, and many record forms a file. So this is the data hierarchy. So data files, record keys are there, identifies a record to facilitate the retrieval of a specific record. Like, you may ask one question: select all students whose name start with A. Okay, and surname is equals to null. So what it will find, actually, it will find all those records where students are not using their surnames, only names are there. So this type of things are also there with a record. So you can search directly. It identifies the record to facilitate something, and sequential file records typically sorted by key. Okay, this is random file, and sorted by key means roll number, sorted by your roll number. Your attendance list is sorted by your roll number. Files and streams. So streams, okay. Everything is treated by C as a file. C views is file as a sequence of byte. Each file as a sequence of byte. File ends with end of file marker. So end of file markers are there. We can run the for loop for I equals to 0, I is less than end of file, I plus plus. And then this will print the record. Print %s, comma, record I. Okay. So this loop simply says that this loop will work. This loop will read the file until end of file is encountered. Stream created when a file is opened. Okay, whenever we are creating a file, this is the stream, structure of a stream. Okay, so it will read the file and it will provide the output. Like a stream of input output, whatever we are using in printf and scanf. So there are different type of streams. Provides communication channel between files and program. So this is our file and this is program. Okay, this is our file and this is a program. So it will establish unidirectional communication as well as bidirectional communication, but bidirectional communication with a certain degree of security. Then come to different file pointer. So this we have already learned about file. Now, because file is a dynamic entity, it is stored in memory. So you want to access stored in memory. So to access such thing, we need pointer and pointer of file type. Okay, so it will open the file as earlier discussed, that bit followed by character, character followed by field, field followed by record, and all the records makes or compose this as a file. So what is a file structure? Before this, standard input is the this is stdin. Okay, so this is standard input through keyboard and standard output through screen and standard error through screen. So all these you will be learning in Unix subject also. Whenever Unix will be in your syllabus or in your semester, then you will learn definitely this thing. So just don't avoid it, because these commands are very useful. And this is actually library functions also. Now come to file structure. So this file is a pointer. Okay, file type structure or file type pointer, it will always point to file type of entity. File descriptor is is the index into operating system array called the open file table. So file descriptor is actually one integer value. Okay, and this integer value, upon success, it will return positive values. Okay, for success means if file is available, then it will return positive value. Otherwise, negative values will be written upon failure. Fine. File control block, and this thing you will learn in next semester, that is third semester, not in second semester, as a subject operating system. Okay, in operating system, process control block will be coming in first unit, but let us try to understand or simulate. Whenever we are storing anything in memory, it is written in terms of program code, program segment, okay, or code segment, data segment, stack segment, extra segment, etc. So how do we, but these are the entity of primary memory. Now in secondary memory, chunks are there. Inside that chunk, this file control block is stored. Okay, so this file control block will, this is what? This provide metadata about file. What is metadata? Metadata, like a person's metadata, is what is complexion, what is eye color, what is size. Okay, this is a metadata for a person. Fine. Similarly, for file, from which place to which place it is stored, and how do we access the file, how many blocks are allocated to that file, that is known as file control block. Now come to files and streams. Read write function is standard library. So there is app-get-c. This reads one character from a file. Okay, and it takes a file pointer as an argument. App-get-c, this is standard in, means standard input stream. This function will be standard input stream equivalent to getChar function. Put c writes one character to a file, takes file pointer and a character to write as an argument. So whenever putting means we are putting to that file. Here in app-get-c, we are reading from file, and this is writing into file. This is our file, and we are reading from file, and this is writing into file. Now it takes a file pointer and a character to write as an argument like this. Put c a comma standard output is equivalent to put character a. Okay, both the things are same. As versions are modified and enhanced, then it will change to certain thing, because it is inbuilt thing. Each and every time we need to write a standard out. Okay, there is no meaning of writing this. Why? Because standard out, we know, system know that without a standard out you won't be able to put the character. So that's why they have created another function, and that is put character. App get s for string. Okay, or so this will read a line. Okay, whatever line contains, so it will read the entire line. App put as writes line to a file. Whatever line you want to write, you can use app put as function. App scanf and app printf is very similar to printf and scanf. Okay, but it is scanning from file, like whatever data we are providing in CSV file, it will be scanned from that, or it will be read and print into that file. Okay, scanning means we are writing into file, and this is scan and this is print. C imposes no file structure, no notion of record in a file. Programmer must provide file structure. So this is very important thing, because if we bind the file to a dedicated structure, then how do we write? So that's why we need to provide our own file structure. Creating a file. So how do we create a file? So this is the file type data. File type pointer, my pointer. Okay, it will point to file. So whenever we are, because already told you that it is stored in secondary memory, you need to access it. For this purpose, memory management operation is required. Whenever memory management operation is there, it always involves pointer. Okay, so that's why pointer is there. My pointer equals to, now it will opening the file. So it is opening the file, and what is the name of file we need to provide? My pointer, this is my pointer, equals to f open my file.date. Mind it, this is double quote, and this is the name of file. Okay, and then open mode. So there are three open mode: read, write, and execute. We commonly deals with read and write only. Execute mode is not often used in C program. Function fopen returns a file pointer to file specified, takes two arguments, file and open, file to open and file open mode. If open fails, null will be written. Okay, so this is this file is a descriptor also, and if returns null, it means it will provide error. Printf, this is used to print a file. Okay, whenever we want to print a particular file, print inside the file, like printf, except first argument is file pointer to which file we are going to print, and that's it about. Now file end of file. This is also a file pointer. It returns if and of file indicator, no more data to process is set for the specified file. App close will close the file whenever we are opening the file. First thing is we open the file. Okay. Second thing is we close. Either we read from file, we write into file, and finally we will close the file. So it is very important thing. Closes specified file performed automatically when program ends, and good practice to close file explicitly. Otherwise, one can write or some garbage will be there inside that file. Program may process no file, one file, or many files. Each file must have a unique name and it should have its own pointer. So this is our open mode. Okay, we have already discussed open mode. What are the different open modes we have talked about? See, this is general. Read, write, and execute. Now here just see what are the different modes. First thing is read, means open a file for reading. Second thing is write, create a file for writing. If that file is already existing, then discard the current content. Whatever contents are there, it will erase and then overwrite over this file. While append and write, there is a difference between append and write. Append opens or create a file for writing at the end of file. It removes all the data and then write. Okay. In this case, if the file is available, then it will start writing from and last line. And this is also known as appending. Then R plus open a file for update, reading and writing. R plus means you can write inside that file. W plus, it will create a file for update if the file already exists and discard the current content. You know very well. Okay, we are updating the file. Okay, we are appending, although it is updating, but writing is done at end of line. So three different modes. Forget about these modes. These are standard modes. Okay, we will discuss in Unix operating system when Unix operating system will be in your syllabus. But this time it you must remember read, write, and append. Okay, read, write, and append directly, and there are one more mode, read plus, W plus, and append plus. It will update the file. Okay, it will simply write into file, it will simply append into file, and it will simply read a file. But this write plus, read plus, and append plus will update the file. Now this is very simple program to read a file. Okay, how do we read a file? So just start with stdio.h, and there are different characters which we want. Actually, it is not for reading, it is for writing. So first we are going to write into a file. So first of all, we will declare what variable we want to put. You can also use structures. Okay, struct record, and then it will start writing integer account, then character name, then and this name is of string type, that's why 30, and then double balance. Okay, and then final semicolon. And if you want to write it with type def, then type def, and then this record is record. So now you can use this as record type R1. Okay, and then R1 dot account. This is account. Okay, so equals to 1, 2, 3, 4, etc. R1 dot name equals to whatever you want to write. Okay, and then R1 dot balance. So this is means you can convert it into structure or union. But in this program, we have not converted into a structure or union, just trying to use as organic. Okay, organic means or atomic. Atomic means individual values we are using. Then come to file type variable, and this file type variable is CFPTR. This is a file pointer for particular file. Now, this is the standard way. You just try to understand this. You need not to use this. I can write this statement as like forget about this if. Okay, I can write this statement. I can replace this statement as CFPTR equals to F open and then the name of file which we want to open, clients.dat, comma, writing mode पे हम we will open this. Okay, so this is one statement which will open this file if exists, or it will return some negative value. So how do we find? And then we will start writing if CFPTR. Okay, if CFPTR, if this is means this FPTR. Okay, let me convert this statement. Equals to null. Okay, means this value is not available, then it will print error, file not found, or else the remaining operation will be performed here. Okay, so this is very important thing, and just try to understand that you can use this statement, and this is the standard practice. Okay, we use physics standard of writing C program. So this physics standard is portable operating system interface for Unix like system. So for that we use directly. It will either return null or not null. If it is null, then it will not open the file, or if it is not null, then this descriptor will return particular value. This is any integer, positive integer value. Okay, and this positive integer value is just a pointing value where it is going to point. It is just a kind of process number, you can say. Now else means now file is available with us, so we can enter the account name and the balance. So printf enter end of file to end input. Okay, so we will write EOF, automatically it will end the input. And now printf, so question mark is given. In this question mark, it will start scanning the thing. So first thing is %d means account. Second thing is %s is the name string type, and %lf is the balance. Okay. Now while FEOF standard input, until we reach, we are not given the end of file, it will start printing the file, content of file. So content of file is CFPTR is, it will open the file. It is the name pointer to file. Okay. Second thing is %d, percentage, and %.2f is the data. So it will automatically print the record into file. Which file? This file. Where is that file? This file is declared at this line, and this file is opened by this command. Okay. So it will automatically points to that file. Client.dat. And then it will start printing into file, and then again printf, it will ask the question, and until I provide end of EOF, it will write into the file. So, and then finally we will close the file. So in this program we have write some data into file, but we have never read the content of file. Okay, so this is the style of writing into enter end of file to end input. So what is end of file? It is not EUF. Just press 2 times enter, then automatically it will skip from the program. So enter the account name and balance, enter end of file to end input. So we have entered using this question mark. In previous slide, you have already seen that this is the question mark, and this is our question mark prompt. And once again, the question mark prompt, so we scan the content. First scanning is there, and then until the end of file, means double enter is not there, it will scan the content. So this is the file which we have stored. Now let us see how do we read the content of this file. So reading a sequential access file means sequentially data is stored and you need to read the sequential access file. So first thing, you need to create a file pointer because you want to go for a file related operation, and for this purpose, because file is stored in secondary memory and you are carrying it into primary memory, you need to find particular address. Okay, so for that purpose we use my pointer equals to fopen. Whenever we are using this command, it will automatically open or copy the file into main memory. My file dot dat, and the mode is R. Okay, this is for reading. So always remember what you want to open file. Just put the file name and how you want to operate into that file. So reading, okay, means reading means you won't be able to write anything during the operation of this program. Use fscanf to read the file. Okay, fscanf, fprintf, print into file, fscanf, read from a file. Like scanf, okay, scanf will read from keyboard, but fscanf will read from file. You need not to type anything. So fscanf, to whom you want to open, the name of file pointer. Okay, you cannot write directly the name of file because before this you need to use this operation, or you can also do the different thing, fscanf, but if file does not exist, then this will give us an error. So just put fopen here, fopen, and followed by my file dot dat, comma R, and then remaining other arguments as given here. Okay, whatever written here. So you can use this also. And I think this is very simple statement. First, you need to write in this way, and then you can directly use fscanf. So data read from beginning to end. Okay. Whatever file is there. So it will start reading from this point to this point up to end of file is reached. File position pointer indicates number of next byte to be read or written, not really a pointer, but an integer value. Okay. So I had already told you about this descriptor and all other things. These are integer values. Specified byte and location also called the byte offset, from which place to which place. And now there is another function that is rewind my pointer. My pointer to whom you want to rewind, because file is stored in tape. Okay, that time tape was very common. So that's why the rewind function is there. So this will rewind the file. Rewind the file. Reposition the pointer to beginning of file means you have started reading the file. As soon as I write the rewind, automatically it will reach at 0. Okay, upon writing rewind. So this is the program. In previous program, we have write into file and name of file was client.date. Now here another program we have written. These things are very similar. Okay, things are very similar up to this place. Any file related program, you need these things. First thing is data associated with the file, and second thing is means actually this is not data. You can directly uh, give them name as fields. Okay, and then this is the file pointer. It is very important thing. Now once again the same system call we have used, cfptr equals to fopen, then file name, and it is open in read mode. If it is equals to null, it means file is not available. So it will close, it will generate an error message, file could not be opened. If it is not so, then it will start scanning. Okay, this will print into a screen that it will y minus 10 is written, y minus 10 s is written percent 10s, because it is writing account from left and up to 10 position. Okay, so 1 2 3 4 5 6 7. Okay, so let me show you 1 2 3 4 5 6 7 8 9 10. Now come to next thing, that is percent minus 13s. Okay, all these things whenever we are using minus, it is left justified. What is the meaning of left justified? You can see that minus is written here, but here means whenever we are writing something, so this again minus, but last one is not written with minus. This last one is not written with minus. So this is right justified, and this is known as left justification. Left justification means it is aligned towards left. Okay, all the lines are started from same position. So that's why these complicated statements are written, and all these are a string. This string is going to here, this string is going here, and this string is dedicated for balance. Okay, so this will print only, that's why percent s is written. Otherwise whenever you are reading, so percent d, first thing account number is integer type, and name is string type, and balance is of floating point type or double type. That's why it is written. And then the last very common operation, while writing also we done the same thing. In case of writing, what we have performed here, we have printed into file. Okay, printed into file. This data is scanned from keyboard and printed into file. But here what we have done, nothing has been printed. Okay, means nothing has been scanned by a user. It is directly scanned from file and it is printed. It is printed, and then after reaching end of file, due to this it will close the file, and finally return 0. So this is very simple program. You can write two programs now, that reading a file and writing into a file. First one is writing into a file and second one is reading from a file. Then there are choices. Okay, now this is the program. Writing and reading is okay. Writing and reading is done. So now what's next? Next is query. How do we query a document? Okay, the document is written as that file. Now the same thing. First 4 lines of any program related with file is uses same thing. Even not first means first 6 lines are the same. Up to this 6 line, the original play will start from this line. So else printf enter request, enter request. So there are, this is a menu driven program. First is list account with 0 balance. Okay, so it will search for whether balance is 0. Second is credit balance, and third is debit balance. Means whether it is negative, it is positive, or it is 0. Fine. Now it will scan your request because it is normal program. It is scanning the request. Okay. Now, while request is not equals to 4, request is not equals to 4. This is our request number 4. App scan app. See, this is our file name. Okay, file pointer. So we have pointed the file into particular position. Then it will read that content. It will read the content. Okay, these are the content, and these contents are stored at these location: request, account, balance, and name. Fine. So we have stored, we have copied the content of file into our local variable for this particular instance. Now this is our menu driven program. So obviously for menu driven program, we use switch case, and it is preferred over if else. Okay, now case 1, this request is, it may be 1 2 3 4. So this is our integer value. So what is case 1? Case 1 is list account with 0 balance. It is very simple, account with 0 balance. So the while loop will read entire file, read entire file, and it will check because balance is copied. Okay, balance is copied from file into this balance. So it will check whether balance equals to 0 or not. If it is 0, then it will display all those record whose balance is equals to 0. And again it is reading, and this reading and writing of content will done until the end of file is written, and then break. Okay, after that, if user wants to any other query like credit balance, so it will check whether the balance is okay. For credit, it is negative balance. Okay, so whether the account is having negative balance. So like loan. Okay, loan account you want to search. So loan, for that we just search balance, and we are just reading from file, and it is stored into balance. That's why it will able to do the same task. And similarly, greater than 0 is used for debit balance. It is actually your main account or principal account. It is loan account and it is saving account. And finally, this will close the menu. Then we will reposition the file into that place. If we are not doing that, then it may happen that it will start from this particular position instead of 0th position. And then this is end of run, and finally the program will close. So this is the menu driven program. It is asked for menu. User has entered 1 account with 0 balance. It is shown by this 300 white 0 and 2 account with credit balance minus 42, and account with debit balance. Already we have stored all this data. Okay, so this is the execution of program. So with this, we completed our file management system. If you have any doubt, you can ask. Any doubt? Okay, fine. Thank you. So we will conclude this unit number 5. If we will see any other topic left behind, or from tomorrow, we will revise all the concept. Okay. So thank you very much. Have a nice day. Have a nice time.
Thank you, sir.